Hello everybody. In this video we are looking at one of the exceptions that you may encounter in your Spring WebFlux application, which could be related to blocking the event loop thread, which can arise because of any of these APIs that we may use, like the BlockFirst or BlockLast. So we'll start by looking at what Spring WebFlux is, a brief intro about it. Then we will look at its threading model. And after that, we'll look at an example scenario using which we will reproduce this error and as well as understand what the solutions are. For the impatient among us, the two solutions that I could find is first, you embrace the reactive framework properly so that you avoid using block altogether. The second would be to use blocking on a dedicated thread pool. As I mentioned about the event loop earlier, we don't want to do these operations on the event loop, right? And if we spin up a dedicated thread pool and do these operations on that, you should encounter such kind of issue. So with that, let's define what Spring WebFlux is. So it's a reactive non-blocking framework for building web applications. We are familiar with Spring Boot, so it's just another sibling of it. It's reactive and non-blocking. Now let's talk about the threading model of Spring WebFlux. So this snippet, we have taken it from their website, so feel free to go over it by pausing the video. But otherwise, on a very high level, you would see a server thread and request processing threads, so which together forms the event loop that I have been talking about so far. Other than that, if you are also using web client by default, which we will use to kind of to call the other APIs. So by default, both the client, the web client, and the server which will accept the request, right, will share this event loop, right? So these two thread groups or the thread pools that we have is related to receiving the request as well as making requests to any further APIs that we may have. Now, other than that, we have thread pools, provided by the framework itself, which are like parallel thread pools, which are meant for CPU bound work, and elastic thread pools, which are for IO bound work. And finally, you can also see some data access library thread pools or any third-party dependencies that we may have, because this scheduler framework, which gives us this parallel and elastic thread pool, also allows you to create a custom thread pool. So you may see a third-party library creating their own custom thread pools. So with that, let's jump into the scenario using which we will deep dive into this example. So we have a restaurant called the Protein Bar, and it has menu, right? And menu has menu items. So whenever you are trying to create a menu item, it needs to be enriched with nutritional information, for which we're going to be calling a nutrition API, and which will provide us the nutrition information. And that's where we're going to see how we may encounter this issue and also see the right way of doing the same. We have this nutrition API over here. As mentioned earlier, this API will just give us some nutritional information about a menu that we may have on the protein bar. So let's start this API first. And we go to this API, which is V1 nutrition and some menu name or recipe name. And then we're just gonna get some hard-coded information from here for the demonstration's sake. Now, the main stuff, right? The protein bar API. So what do we have here? So here we have a router, which is for the V1 menu path, and it is going to a handler for creating a menu. And here, if we see create menu item, and we get the menu item from the request body, and this map, right? So map the nutrition API client enrich, right? So we have a nutrition API client which will enrich the menu item with the nutrition information. Now let's look over here. What do we have here is the web client for the nutrition API. It'll retrieve and then it'll block, right? So what we are doing is from the web client trying to get the nutrition information while blocking, and then once we have got the nutrition information, we are trying to create a fresh menu item and sending back the response. So let's start this API and see what happens. And while it starts, we'll head over to Postman, and here I have a sample request which is showing us we are trying to create red sauce pasta and these are the ingredients, right? So I'll post. We see we get a server error. So now if I go back to my IDE and see what happened, yeah, so the error that we started off with, we have got that error. So we have successfully reproduced the error. Now the solutions that we mentioned, like how we can solve this potentially, and we said there are two ways to solve it. Let's look at them one by one. So the first solution that we're going to be looking at is blocking on a dedicated thread pool. Now what does that mean? As we mentioned in the introduction and in the threading model of WebFlux, WebFlux framework provides us with certain thread pools that we can use whenever we have, either heavy CPU or IO bound operations. So this calling of the nutrition API is a typical IO operation that we may see in our API servers, right? So how do we go about it? So this actually is very simple. What we have to do is just go to the menu handler here, and all we have to do is use an operator called publish on, which is to say that whatever is the result of the previous step, that is body to mono over here, publish that on the bounded elastic thread pool. So now the results which were just flowing on the event handling thread pool will be moved to the bounded elastic thread pool. So if I were to just restart my application now, and I haven't changed any other piece of code, it's just this single line of code which has been added. So now my API has restarted, and if I go back to Postman and try to hit the API once again, you can see we are getting back the response. So the reason we didn't encounter the exception now is this operation of blocking is no more happening on the event loop thread. Now let's look at another solution, which is embracing the reactive. What I mean by that is writing idiomatic code. So we use the WebFlux framework as the way it is supposed to be used. So how we can do that? Let's head over to the IDE once again. And here we notice there is a bit of an issue with the code over here. So what we are doing is we are mapping, that is we are getting the value here, and instead of returning a mono, what we are trying to do is we are trying to get the value exactly. That is, it's not wrapped within the reactive constructs, right? So let's change that and see how we can work without blocking. So if I change this definition to say return a mono instead of a menu item directly, and instead of blocking, what we can do over here is use map, right? So here we are getting nutrition, and we're gonna just use that. Sure. Take this off from here, right? And return this directly. Okay, now let's restart our API once again. Meanwhile, let's head over to Postman. I'll make sure the API is restarted. Yeah, it's done. So going back to Postman once again. Oops, I think I missed something. Let's head back and see what happened here. So we did change the contract here, but we didn't change it back over here. So now instead of doing a map, we have to say flat map over here. So let's restart it once again and head back to Postman. There you go. So with that, we have seen two approaches how we can potentially work around the illegal state exception that we may encounter because of using the block. Hope you learned something from this video, and if you did, make sure to hit the like button and subscribe to the channel. Thank you. Happy coding.